Good morning, everyone, and thank you for making your way to the mat in such a quiet and civilized manner. Our interactive whiteboard is broken today, so we'll be using all our visuals off my laptop. So you need to pay close attention because the screen's not as big as what you used to. So please ensure you're in a position on the mat where you can actually see myself and also the screen quite clearly. I would like to start our lesson today with a quote by Nikolai Lobachevsky, a Russian mathematician in the 1800s, who said there is no branch of mathematics, no matter how abstract, which may not somehow be applied to the phenomena of the real world. So what he is trying to say is that everywhere we look in nature, maths is involved. You must understand that maths is not just about your times table or addition. It's far more diverse and exciting. Maths in nature is viewed as a phenomenon. So as I previously mentioned, a phenomenon is an extraordinary circumstance or an occurrence. I think that most of you would be unaware of the mathematical work required to explain something very simple and common in nature that I'm sure that you look at every day out in the playground. Let it be a leaf, a flower, or even a butterfly. On Monday, we began to discuss maths in nature and the various math phenomena that exist within nature. Can anyone remember any of the examples of the maths phenomenon in nature that we discussed? Corey? Fantastic. Chloe? Fantastic. That's a really great recall. They can be hard words to remember. So if we look at my screen here at the moment, let's have a look at those that we discussed earlier in the week. The first one we have is the Fibonacci sequence that we can see here with the cyclone and also here with the stars up in the galaxy. We then also have perfect geometry here with these beautiful shells here. Next we have symmetry with this butterfly. So what that's trying to say is that if we were to fold that in half, image is exactly the same on both sides. Next we have the geometric pattern on this beautiful flower. Tessellation, so within a beehive you have exactly the same shape that is joined together and multiplied. And then lastly in this beautiful core of the flower, a spirograph. So in the middle here it slowly turns out and out. Now today we are focusing on spirals in nature. So spirals are a curve which turns around in some central point, getting further away or closer and closer as it goes. So spirals in nature can be seen in many ways, such as seashells, snails, pine cones, roses, a cyclone, even their fingerprints. I've brought in examples of spirals in nature which I place on a table beside my desk, and these samples will be available for you all to take a closer look at during free time and allow you further to understand that the magic that is maths in nature. It is very exciting, and I hope that these maths sessions give you a newer outlook into how exciting and broad maths can actually be. So today we're actually going to be looking at the nautilus shell, which is this one here. If we all have a closer look here at my laptop, we can see that shell there. Okay, so the nautilus shell is a beautiful natural spiral. Okay, this shell of the nautilus are most apparent as equiangular spirals. There are mathematical equations that go with equiangular spirals, but are equations that you will come across in high school. Today, I just want you to be aware of the existence, but not of its formula. Previously, we have worked on angles and the idea of degrees. So we've talked about right angles, straight angles, 30 degrees, 10 degrees. Equiangular spiral is a spiral such that the angle between the tangent and the radius vector is the same for all points of the spiral. It is also known as the logarithmic spiral due to the way that the spiral arms increase in distance from the center of the ratio. So as it turns around, the arms slowly get larger and larger. Can everyone please sensibly point their finger out straight and slowly make a motion like you're making a spiral. Can anyone notice as you move your arm out further, a bit further at a time, it actually makes the spiral larger. Very exciting, isn't it? Have you guys ever found a seashell in the ocean and seen an animal living inside of it? Well, as far as the animal that lives in a shell grows, it needs the shell to grow in the same proportion in order to continue to live within that shell. For today's activity, I have placed a large piece of paper on everyone's desk. Okay, so to complete this activity, you will need your protractor, which you should have in your tub under your desk, and also a pencil and a ruler that should also be in your tub. Now, I want you to make a point. I've got this as an example. I want you to make a point in the middle here, paper. Then with your ruler, I want you to draw a straight line going out 5 centimeters. I then want you to place your projector on that line and then mark out a 30-degree angle. Using your ruler, again, starting at the same point, I want you to then draw out a line from the center, going through the line at 30 degrees, and mark this time, taking your line to 5.5 centimeters. I want you to continue doing that, increasing your ruled lines by 0.5 centimeter. As you're going along, I want you to join the dots to make your way back around to the start. In the end, you should have this amazing equiangular spiral. So please take your time, okay, as it requires precision. Good luck, and I can't wait to see them all.